All right, let's jump right in. Welcome to this explainer. Today, we're going to bridge that absolutely critical gap between Python AI research and live algorithmic execution. And we're doing it completely natively inside MQL5. If you've spent months building the perfect neural network in a lab setting, only to feel that crushing frustration when it fails in the live markets, maybe because of execution lag, messy API bridges, or those dreaded timeout errors, well, you are in exactly the right place. We are going to solve that bottleneck once and for all today. So, as an aspiring professional quantitative developer, consider this your masterclass syllabus for the MQL5 ONNX engineering lifecycle. We've got 6 quick stops today: bridging Python and MQL5, matrices and vectors, model creation, shaping geometry, native inference, and finally, resource cleanup. Let's get to it. Section 1. Bridging Python and MQL5. Let's start by looking at the big picture, the major paradigm shift you need to make to move your AI from a sandbox right into the live market. There's a massive contrast between these two environments. Researching a model in Python? Well, that's incredibly flexible. It's forgiving. It's literally designed for exploration. You can load these massive multi-gigabyte pandas data frames into memory without a second thought. But deploying that trained model into a MetaTrader 5 expert advisor, that demands something completely different. It requires strict, high-performance, real-time resource management. The live execution environment simply doesn't tolerate sloppy memory allocation or slow data processing. If you try to run heavy, unoptimized data loops on a live per-tick basis, no way, you'll freeze your trading terminal instantly. Traditionally, algorithmic trading relies pretty heavily on standard indicators, right? Like calculating a simple moving average on close prices. But we are moving way beyond that. We're talking about building a custom invisible neural network engine under the hood, operating on entirely different mathematical principles. Instead of just staring at a static, lagging indicator, an AI engine dynamically weights hundreds of hidden features all at the exact same time. It's calculating complex, nonlinear relationships in real time, executing predictive logic instead of just reacting to what already happened. Section 2. Matrices and Vector Integration. Okay, so before we can actually run that AI, we have to prepare our data efficiently. In the past, if you wanted to process complex arrays in MetaTrader, you often had to write these incredibly complex, custom dynamic link libraries in C++ just to get the speed you needed. Honestly, it was an absolute nightmare of debugging. But now, MQL5 literally translates familiar Python NumPy methods directly into its native language using matrix and vector types. Guys, this is a total game changer. You can manipulate complex datasets natively with extreme efficiency. You've got functions like matrix.argmax, which grabs the index of the maximum value along an axis. You have matrix.percentile and matrix.flat, which lets you address a matrix element with just one index instead of 2. It's essentially the raw power of NumPy built right into the core of your trading platform, saving you countless hours of integration headaches. And by leveraging these native matrix methods, you completely avoid writing clunky, computationally expensive nested loops. Your code becomes simpler, way cleaner, and a lot closer to actual mathematical notation. Let's think about computational complexity for a second. In algorithmic execution, moving your data processing from an O of n squared nested loop down to highly optimized matrix operations is absolutely crucial. In a high-frequency live trading environment, every single microsecond you save on data prep can literally be the difference between a perfectly filled order and a completely missed market opportunity. Moving on to Section 3, the engineering bridge. The ONNX lifecycle. Now that our data structure is solved natively, we need to architect the professional lifecycle of our ONNX model inside an expert advisor. Every robust AI trading system follows 4 specific architectural pillars. Step 1, create, laying that mathematical foundation. Step 2, shape, defining the strict geometry. Step 3, run, actually firing up the inference engine. And finally, Step 4, release, which serves as our vital cleanup crew. So, Phase 1, model creation and security. Our very first operational step is safely loading the ONNX model into our live trading environment. Now, sure, you can load a model from a local file path, but using the OnnxCreate from buffer function, that is a vastly superior expert design choice. Let's break down how this works practically. Instead of relying on disk reads every single time the EA initializes, this method lets you compile the entire ONNX model as a byte array directly inside your compiled .mq5 file. This locks your model's resources securely into memory. The massive benefit here? Intellectual property protection. The end user doesn't need to download or juggle separate .onx files. Your proprietary AI is safely embedded and completely secured from external tampering or theft. Next up, Phase 2, Shaping Data Geometry. With the foundation poured and secured in memory, we now have to define the precise geometry our model expects. In machine learning, shape just refers to the exact multidimensional tensor geometry required by your network. We use the native functions OnnxSetInputShape and OnnxSetOutputShape for this. We absolutely must tell MQL5 the exact dimensions of the data flowing into and out of our model. For instance, if your model was trained in Python to expect a 3D tensor, batch size times steps features, but your EA tries to feed it a flat 1D array of close prices, the execution will instantly halt. Geometry is everything here. So, here's a highly actionable pro tip for your codebase. Dynamically verify your model's architecture. Use native functions like OnnxGetInputCount and OnnxGetOutputCount, along with OnnxGetInputTypeInfo to query the model directly. But timing is key. You really want to code these dynamic verifications straight into the OnnInit function of your expert advisor. Why? Because if there's a mismatch, the EA fails safely the exact moment you attach it to a chart. That is infinitely better than having it successfully attach, only to violently crash during a live trade inside the onTick function when it hits unexpected geometry. Let's look at Phase 3, Native Inference in Execution. This is where we arrive at the execution phase, the true engine room of our expert advisor. The OnnxRun function is your native inference engine. It takes that perfectly shaped matrix data and processes it to generate live trading predictions. What is absolutely incredible here is that it calculates these outputs in real time as new market ticks arrive, completely inside the MQL5 ecosystem. Think about how we used to have to do this. We'd write tick data to a local CSV, have a Python script constantly scanning that folder, calculate the prediction, send a webhook back to MetaTrader. The latency was horrific. Slippage was practically guaranteed. But now, it's pure, local, C++ level execution speed. Zero latency, zero external bridges. And finally, Phase 4, Resource Cleanup and Performance. This final phase is what really separates the amateurs from the senior quantitative engineers. Strict system cleanup. Listen, memory management in an always-on trading platform is non-negotiable. When your EA is unloaded, maybe you're changing timeframes, updating parameters, or just taking it off the chart, OnnxRelease is your crucial cleanup crew. You specifically want to place this function inside the OnnDNet block of your code. It makes sure your ONNX model is safely detached, giving that critical dynamic memory straight back to the operating system. Consider this a very serious warning from the trenches. If you forget to release your ONNX resources, you are going to cause compounded memory leaks. And in high frequency or really even standard algorithmic trading, memory leaks compound exponentially. If your code leaves even a few kilobytes of undeleted dynamic objects hanging around on every single tick, you'll eat up gigabytes of RAM in a matter of hours. During peak market volatility, this will literally cause a catastrophic freeze of your trading terminal, leaving all your live open positions totally unmanaged. MQL5 will try to warn you in the journal about undeleted objects, but honestly, by then, the damage is already done. So always use OnnxRelease. So what does this all mean? Well, now that you understand the complete architecture, how to securely create, shape, run, and release ONNX models using those lightning-fast native matrices, the execution bottleneck is completely gone. The bridge between your Python research and your MQL5 execution is finally clear. The tech isn't holding you back anymore. The only limit is your imagination. With latency eliminated and native integration right at your fingertips, what market inefficiency will your AI conquer first?